In this video, I'll be solving the fifth part of first problem of UPSC Civil Services Mains 2023 Statistics Optional Paper 1. So we are asked to differentiate between prior and posterior distributions, and in case of squared error function, we need to find out the Bayes estimator for unknown parameter. So first of all, prior distribution. So prior distribution is the probability or density. So like before expressing our belief about the unknown parameter, so before seeing the data. So basically it's the probability or density expressing our belief about the unknown parameter theta before seeing the data, whereas posterior distribution is it's our updated belief about the parameter theta after observing the data. So generally posterior distributions they are obtained by using the Bayes rule. Pi theta given x is nothing but L of x given theta into pi of theta divided by integral of L of x given t to phi of t dt, where L is nothing but our likelihood, and all Bayesian inference like point estimates, intervals, predictions, they are all based on this posterior distribution. So if we consider the loss function, the squared error loss function now. So squared error loss function is L of theta comma a, where it is nothing but theta minus a whole square. So a is our estimator. So estimator or decision based on observed data, like based on observed x is equals to x. And Bayes estimator, let's say delta star x. Suppose like this is our this is our Bayes estimator that minimizes the, so this is Bayes estimator that minimizes the posterior expected loss. So therefore this delta star of x is nothing but argmin of a, expectation of theta minus a whole square given x is equals to x. So that means it is argument of minimum value of a, integral theta minus a whole square pi of theta given x d theta. So differentiating this particular posterior with respect posterior risk, we can term it as a posterior risk. So differentiating this posterior risk with respect to a will give us d by dA integral of theta minus a whole square pi of theta given x d theta is minus 2 integral theta minus a pi of theta given x d theta. So that is nothing but minus 2 times expectation of theta given x minus a. So equating it to 0, that means it gives us a is equals to expectation of theta given x. And if we find the second derivative is 2, which is positive. So that means at a is equals to expectation of theta given x, the Bayesian risk is, the posterior risk is minimum. So therefore this Bayes estimator under the squared error loss is nothing but the posterior mean. So delta star x is nothing but expectation of theta given x. So therefore the Bayes estimator under this squared error loss for this unknown parameter is just the posterior mean. So that's it for this video. We'll meet in the next video.